This is for Year 11 specialists. We're looking at exercise 23a, and we're looking at how to form equilibrium triangles and solve triangles. So we need to know what forces are acting on the object. So the object happens to be a mass. It's 5 kilograms. So 5 kilograms is going down, and it's attached to a wall, to string which are attached to walls, which means that the object's not moving because there's T1 and T2 tensions stopping it from going anywhere. Now, since these, we can use them to draw an equilibrium triangle. Now, if we were given, say, lengths instead, that doesn't work. We cannot put lengths on equilibrium triangle because equilibrium triangle is for forces only. So you got to make the distinction. Usually when they give you lengths of something, it's to help you find the angle in between the string and the wall. In this case, we're given those, so we're not trying to find that. We can go straight to the equilibrium triangle. Now, I need to draw an equilibrium triangle, so I know that I can use the 5 kilogram weight because that's a force. It's going down, and T2. So I can draw it in different orders if I wanted to. I'll put T2 here, so because it's sloping that way, and T1 is obviously sloping the other way, so I'll put T1 here. The reason why I did that is because it forms a nice triangle. Now, that's all and good. I can't do much with that at the moment. I need to find what the internal angles are. Now, to do that, we can look at the original diagram. I can see that T1 and the horizontal and the ceiling makes a 45-degree angle. Now, I can imagine that there's a ceiling here. If that's 45 degrees, and you know that the 5 is vertical, it means that this has to add up to 90 degrees because it's a right angle. So that has to be 45 degrees. Similarly, so that has to be 45 degrees. 45 degrees. T2, T1, T2. So how do I work out what this angle is? Very similar. If T2 makes 45 degrees with the horizontal, so that's 45 degrees. If there's a horizontal here, using the Z property, if that's 45, that has to also be 45. So this has to be, this adds up to out of 90, so it has to be 45. And knowing that's a triangle, it adds up to 180, so it means that we've got 45, 45, that has to be 90 degrees. So essentially, drawing the triangle again, we've got 90, 45, 45, we know that's 5, T2, T1. Now I'm going to use the sine rule to solve this because it's a lot easier than the cosine rule. And we've got enough information to use the sine rule. Because I know a pair here, I've got 5 and the opposite angle being 90, and another pair. I have one unknown and one known angle. So I can use the sine rule. So using the sine rule, I know that I want to put the unknown at top. So T1 divided by sine 45 degrees equals to, and the other pair, 5 divided by sine 90 degrees. Now, I know that rearranging, I know that T1 equals 5 sine 45 degrees, and I've got over sine 90. I know that sine 90 is equal to 1, sine 45 is root 2 on 2, so sine 45 is root 2 on 2, 1, so it's just 5 root 2. And because the angles are the same, I can use the sine rule again, or I can realize that the tensions are the same. In this case, not always, but in this case it is. So the tension, T1, is 5 root 2 over 2. I'll show you another example on how to work out angles if we're just given lengths.